Today we're going to do systems of equation word problems. Let's get started. So we can use systems of equations to solve real world problems. We're going to talk about that today. Procedure is going to be pretty simple. Three key steps here. We're going to define our variables. That's like got to be the first thing we do. Pick an X, pick a Y, pick stuff that we are familiar with, and then use that. Write two equations to model the situation, and then solve the system. I think the easiest way to show you all how to do that is through examples. So get this written down, and then we'll go on from there. So example one, a movie theater sells adult tickets and children's tickets. Adult tickets cost $12 and children's tickets cost $8. At one showing yesterday, the movie theater sold 450 tickets, totaling $4,800. How much of each type of ticket did the theater sell? So, if we're looking at our procedure, we need to kind of define our variables. And so what I'm going to do is I'm going to have A equal adult tickets and C be children's tickets, A for adult, C for children. And then from there, we kind of need to create an equation. So what I did was yesterday, the showing yesterday, a movie theater sold 450 tickets. So adult tickets plus children's tickets equals 450 tickets. Okay, feel good about that first one. And then I also know that the total amassed $4,800. Okay. Now this is where we have to connect our adult tickets and our children's tickets. Here I use 12 because I know that $12 is what it costs for each adult ticket and $8 is what it costs for each child's ticket. And then that totals 4,800. From here I've set up two systems of equations and I can solve them any number of ways that we've been learning. I'm pretty partial to elimination, so let's get this set up. Let's not pick red, green, sure. So I'm going to multiply both sides here by 12. I'm just going to pick that one because it's the first one I see. So I'll rewrite it here. 12a plus 12c equals 5,400. And I already have this equation. I've got 12a plus 8c equals 4,800. So at this point, 12a is positive, 12a down here is positive. I'm going to subtract top from the bottom. That's going to eliminate my adult tickets. 12 minus 8 is going to be my 4 here. 5,400 minus 4,800 is, what's that, 600? Yeah, 600. Divide both sides by 4, and I'm going to get 150, okay, wow, 150 children's tickets. All right, that's a great start. If I know that we sold 150 children's tickets, I can plug that back into my original equation using this. So I will have A plus, instead of C, I'm going to have 150 equals 450. Subtract 150 from both sides, and I'm going to say they sold 300 adult tickets here. If I want to, I could go back and check that here by plugging in the amounts into my other equation. 12 times A would be 3,600, and 8 times 150, I should know that off the top of my head maybe, 1,200. Hey, look, those up added together would be $4,800. So adult tickets, 300 bucks, children's tickets, 150. Once you set up those variables and once you set up those systems, then it's just stuff going back to stuff that you already know. We could have substituted. I guess we technically could have graphed, but I think elimination was an easy choice to go with there. Let's move on to another example. No, I don't want you to delete the recording. Example 2. Kiana and Jamal have jobs. The amount of money Kiana makes in 2 hours is the same as the amount of money Jamal makes in 3 hours. The difference between how much they get paid per hour is $6. How much do they make each per hour? All right, so let's define our variables. I'm going to let X equal the amount Kiana makes per hour. And I'm going to let Y be the amount Jamal makes per hour. X and Y are numbers that are letters that we're used to. You could have made it K and J. It really doesn't matter as long as you set it up appropriately and you stick with it. For my first equation, I have 2x equals 3y. Now, why is that? Okay, so Kiana makes in 2 hours the same amount of money that Jamal makes in 3 hours. So here, Kiana in 2 hours equals Jamal in 3 hours. And I know the difference between them is 6. So if I take Kiana minus Jamal, that will equal 6. All right. Now, this is why we know how to use standard form. So we're going to rewrite this first equation here in standard form. Subtract 2x from both sides, 3y minus 2x. Oh, I didn't want to do that. No, I'm going to subtract 3y from both sides, actually. Negative 3y. Brother. Subtracting 3y from both sides will set it up as an x minus y, and that's what I have below. From here, my elimination is going to be a lot easier. I'm going to multiply the bottom one by 2. That's going to give me 2x minus 2y equals 12. And now I'm going to take my top equation here and subtract the bottom one. The x's should eliminate. Negative 3y minus negative 2 is going to be plus 2. So I got negative y, and then 0 minus 12 equals negative 12. So I think that Jamal makes $12 an hour. If I go back to this equation or the other one, this one's going to be the easiest one. Kiana minus 12 equals 6. Add 12 to both sides. Kiana is going to make $18 an hour. Does that line up with what I know? 2 hours would be the same as 3 hours. Yes, Kiana would make 36. Jamal times 3 would be 36. There. So once you set up your variables, you set up your equations well, you should be able to go from there. Let's do another example. Clear all. Example 3. The sum of two numbers is 17. The difference between twice the larger number and the smaller number is 28. So, what are the two numbers? I want to have x equal the larger number, and I'm going to have y equal the smaller number. It could be turned around. You could switch that. Either way is up to you. It just needs to stay consistent. For my first equation, I see here the sum of two numbers is 17. So if I add x and y, that's what sum is, it's going to equal 17. When I see the word difference here, I know I'm going to use subtraction. So twice of the larger number, that's my x, and the smaller number. Twice the larger number minus the smaller number is 28. So here I have x plus y equals 17, 26 minus y equals 28. This is already set up to eliminate y. So I don't have to do any additional work here. I can add these together. X plus 2x is 3x. The y's eliminate. 17 plus 28 is 45, leaving me with x equals 15. Once I do that, I can plug that back into the top equation. 15 plus y equals 17. Y would equal 2. And if I plug that into here, 2 times 15 is 30, minus 2 does equal 28. All right, I think I have figured out this example 3.